Thank you for joining me again on another episode on mathematics with Edu. Quickly, we have today we talk about arc and sector of a circle. Now, when you talk about a circle has a lot of properties, and one of the properties that we have in the properties in the circle are the arc and the circle. Yes, let me illustrate that. You have this, you have a circle. This is the radius of the circle. Let's take this. Then these are the radius again drawn down. So we have a radii. This this is a radius, another radius. So we have this particular one, this length, it is called the length of arc. The length L of what? Arc. Length of the arc. It is the arc, it is along the circumference of the circle. And that is why the formula, the length of arc will always be theta. This is a theta upon 360 times it is along the circumference of the circle, and the circumference of a circle is noted as 2 pi r. Yeah, so you have 2 pi r. Don't forget this formula. So let's solve the question we have. The question says an arc of a circle of radius 14 centimeter. Let's draw the circle. This, take this as a radius. It's drawn again this way. It is 14 centimeter. And they said the length, an arc of a circle of radius 14 centimeter is 21 centimeter long. The length of arc is 21. This is 21 centimeter. It will sustain an angle here. Take it as theta. Then we are not told what angle does it sustain at the center of the circle. Since we know that our length of arc is theta upon 360 times 2 pi r. Please, let's take everything we do here. Let's take pi to be 22 upon 7. Please take that, take note of that. So we're going to be having, our length of arc is already 21. They say the length of the arc is 21. We don't have theta upon 360 times 2 times 22 upon 7, then times 14. 7 here 1, 7 here, 7 here 2. What do we do next? You have 2, okay, 2 here 1, 2 here 1, 1 left in 16, 8, 180, 2 here 1, 2 here 90, 2 here 11, 2 here 45. So by the time you cross multiply, you're going to be having 11 times theta. It's equal to 21 times 45. So you're going to be having this to be 45. So what do we have? Divide both sides by 11 is divided by 11. So let me wipe this. So which means 11 cancel out 11, then theta should be equal to 21 times 45. 945 divided by 11 will have 85.9. degrees. So this is what we have as our theta. Don't forget the length of arc because it is along the circumference. You need the circumference of a circle. That is settled. Is the next question, and that is talking about what's there? It's talking about two. Calculate the one area and perimeter of the sector of a circle. Yes, this one is a sector. If you have a circle, I said this is a radius. Take this as radius. Take this as another radius. An angle is subtended here. This O shape, please note this. This O shape here, oh sorry, have this. It is called a sector. Easy, let me draw it out. A sector has been formed. This O is a sector. It is a sector. So we have a sector here. And how do you go with the area of a sector? The area of a sector, please note that the area it is taken as theta upon 360. Area, look at it, it is along, since it's area, so we consider because it's drawn in a circle, formed from a circle. So you consider what the area of a circle times pi r square. Do you get that? Why the perimeter? Okay, let's deal with this area first. Let's solve the question. So the question, you are looking for the area of the sector. So what do we do? Now with theta, and theta is 60 degrees. So the area will be what? 60 upon 360 times 22/7 times the radius is 7. So 7 times 7. This will cancel out this. This cancel out this. 6 here 1. 6 here 6. What do we have left? 2 here 3. 2 here 11. So the area becomes what? 77 divided by 3. And that will become what? I give it 25.6. 25.6 6, and now you can write as 25.7 is in meters. Then you have meters square. Your area should carry square. Don't forget that, please. So this is what we have. 25.7 meter square. That is our area. The area of the sector is that. Now, what of the perimeter? The perimeter of a sector, let me draw a sector again. If you have a sector, This is it. They have a sector. How do you calculate the perimeter? Number one, this is a radius. This is a radius. An angle theta is here. And it has the length of arc to be this. This place is length of an arc. Is an arc is the shape is in the form of an arc because it's formed from a circle. So the perimeter will be equals to R plus L. And that means 2R plus the length of arc. Isn't it? And what is the length of arc? That's equals to 2R plus length of arc is theta upon 360 times along length of arc is along the circumference, don't forget, times 2 pi r. So it's as simple and direct as that. So let's go now and solve our question. This is the formula we are dealing with. So what do? We write out the formula, the perimeter. Our theta, our radius is 7. So that will be 2 times 7 plus 60 upon 360, then times 2 upon 22 times 2, sorry, they have 2, then times 2 upon 7, then times the radius upon 1. This cancel out this, isn't it? So we move again to this point. So we have, let's continue. Here we're going to be having 14 plus this, cancel out this, 6 here 1, 6 here 6. So what do we have? We have 14 plus 2 here 1, 2 here 3. So we have 14. This is 14. This is 22. And this is 3. Plus 22 upon 3. So that becomes 14. What is 22 divided by 3? We have 7.33. And that becomes what? 14 plus 7 should be 21.33 meters. That is our perimeter. The perimeter of the sector is 21.33 meters. I believe with these few examples, you can now solve questions on length of arc, area of a sector, and perimeter of a sector. Thank you for joining me.